This is lesson 9.4, Graphing Quadratics by Hand. Our essential learning standard for today is I can graph quadratics by hand using vertex form, factored form, and standard form. All right, so I want to begin with a little warm-up. I want to review how to tell which form is which, right? So here we have one of each of the three kinds, right? So which is which? So this first one here, you see it says 2x squared minus 3x plus 5. There's no parentheses or anything like that. That is standard form. Okay? Next one, I see two sets of parentheses. This has been factored. Clearly, it is in factored form. Finally, this one has a number out front. This is supposed to be a 2. And then x minus 1 squared plus 4. This is in vertex form. It's in the x minus h squared plus k form. Okay. All right, so if we want to graph by hand, it's really helpful to have the equation in all three forms because each form of the equation gives you different information about the graph. So we're starting here with the vertex form, which of course gives you the vertex. Remember that the x-coordinate changes sign and the y-coordinate changes the same, or stays the same. So if we come over here to graph this, let's count by 2's along the y-axis. We'll show that by putting a 2 right there. So -2 and then 2, 4, 6, 8, 10, 12. So here's our vertex. So that's going to be the vertex of the parabola -2, -12. Okay, so vertex form tells us the vertex. Next we have standard form. Okay. Now vertex form, there's also something else. The number out front here, which in this case, it's an invisible one, it tells us one more thing. It's almost like the slope, okay? It's almost like the slope of this. So remember, if you square, right, like normal x squared, y equals x squared, 1 squared is 1 when you go over 1 from the center. 1 squared is 1, and -1 squared. So you can actually go up and over as if that one were a slope for the first little points, right? So there's the first couple points of your parabola. So you can actually use the number out front sort of like a slope. It's not technically a slope since this is not a straight line, but you can find the first points going on either side. Okay, so let's now do the standard form of this. Okay, so remember when we square this, you always have to use your box. So we get x squared, 2x, 2x, and 4. And then we also have this minus 12 here. So x squared, add our like terms, plus 4x. And then 4 minus 12 will be a -8. So here's our standard form. So why is the standard form useful for graphing? Standard form gives you the y-intercept. Remember that the y-intercept is where it hits the y-axis. It's where x equals 0. If you put 0 in for the x's, 0 squared is 0, 4 times 0 is 0. You're left with -8. The c, the final value of standard form, is the y-intercept. So we know we have a y-intercept of -8. Remember, we're counting by 2's. 2, 4, 6, 8. So now I have another point. Okay? Now, what about factored form? Okay, so let's do multiply to -8 and add to 4, right? So what will do that? So actually, there aren't any numbers that do this. So this is funny that they asked for factored form because this one doesn't factor. So what we want to do instead is solve for our x-intercepts. Factored form will give you the x-intercepts, but if it doesn't factor, we can solve for the x-intercepts. So what I'm going to do now is take my original vertex form because this is the easiest to solve, right? So x plus 2 squared minus 12 equals 0. So if we're going to solve this, we can add the 12 and then square root it, right? So if we square root both of these, the square root and the square cancel out, and don't forget you have to do plus or minus. Now what about 12? Will that reduce? 12 is 2 times 6, which is 2 times 3. So yes, it will reduce to 2 root 3. And then finally, to get the x by itself, we'd have to minus 2. So x equals negative 2 plus or minus 2 root 3. So those are our x-intercepts. There's two of them, right? Negative 2 plus 2 root 3, negative 2 minus 2 root 3. So if I type these into my calculator to get decimal equivalents, right? So I can do negative 2 plus 2 root 3, and that gives me 1.464. Negative 2 minus 2 root 3, type that in a calculator, and I get negative 5.464. Okay? So in other words, my x-intercepts are at about 1.5 and about negative 5.5. 1, 2, 3, 4, 5.5. So now, right, the x-intercepts. So yeah, this gave us all the information. So our vertex was at negative 2, negative 12. We just got the intercepts, right, at 1.464 and negative 5.464. And we found the y-intercept was at negative 8, right? So now we can put all the information together and kind of make our parabola. And there we go. Okay, so let's look at our next one. Here we have it in vertex form, which is nice because we can get the vertex. Remember, x changes sign, y stays the same. So negative 2, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's our vertex. And then remember that the number outside kind of acts like a slope. This is negative, so it's going to be going down like a negative frown, right? It's negative 1, invisible 1 right there. So it's sort of like we have a slope of 1. So there we have our first 3 points of our parabola. All right, so let's get this in standard form now. Okay, so multiply out our x plus 2 squared. So x squared, 2x, 2x, 4. Now, this had the negative out front. That means that all of this is going to be negative. And then we also have to add 9. So we get negative x squared, negative 4x, and then a negative 4 plus 9. Okay, now that we have it in standard form, remember that the y-intercept is your constant number. The y-intercept will be at 5. So we can now graph this in 1, 2, 3, 4, 5. So this is important. You can tell as you're going if you make a mistake, right? You should be able to see a parabola taking shape, right? Your points should make sense. If you did this and you solved for the y-intercept and you made a mistake and got a number that was up here, you'd know you made a mistake, right? This should make sense, okay? All right, so let's try for factored form now. Since we have this out front, this is kind of a cool trick. If all you have out front is a negative, you can actually just switch the sign of the whole equation, right? As if you were, because it's really like equal to 0. If you times both sides by a negative, that stays 0. It's just fine, right? It's like pulling out a greatest common factor. Okay, so then we want what will multiply to negative 5 and add to 4, right? Multiply to negative 5, add to 4. So that's going to be 5 and 1. 5 times 1 is 5. Which one needs to be negative? We need to add to a positive 4, so it's got to be a negative 1. So there's our factored form right here. Okay, now remember that the x-intercepts are opposite of the factors. So negative 5 and 1. So here's 1, here's negative 5. 1, 2, 3, 4, 5. So again, look, it makes sense. You can see the parabola taking shape. If you accidentally did those backwards, you'd know it right away. So imagine I did those backwards and accidentally put negative 1 and positive 5. Then you can see that those dots don't make sense, right? You can see that those are wrong. Okay, so now all we have to do is connect our red dots All right, sorry, it's terribly hard to draw on the computer, guys, and make our parabola. All right, next one. Ooh, look, it's in factored form. So right away we know the x-intercepts, they're opposite sign of the factors. So I can graph those in 1, 2, 3, 4, 5, and -3, 1, 2, 3. So there we go. Let's get this in standard form. Make your multiplication box. So I get x squared, -5x, 3x, -15. So x squared, -5 plus 3 makes -2x. And there's our standard form. Remember that the standard form gives us the y-intercept. So our y-intercept is at 0, -15. All right, we might want to count by like maybe 3's this time. We can keep counting by 1's on the x-axis, but let's count by 3's so we have enough spaces. So -15, 3, 6, 9, 12, 15. You can label it too, right? There we go. All right, so next one, and this is positive, right? It's positive x, so this is going up. Now let's get this in vertex form. Okay, so we need to isolate the first two terms and complete the square. So divide the middle term in half, and then square it, add and subtract from both sides. So the first three terms become that perfect square binomial, and then the -15 minus 1 is that, and that tells us our vertex. So our vertex is at +1, -16. Okay, so vertex at +1, -16, so that's just barely below it since we're counting by 3's, right? And as you can see, we've made a nice parabola shape if I can draw it on my computer. Okay, there we go. All right. All right, next problem. We have our equation in standard form. So remember, the information we get from standard form is the y-intercept. So our y-intercept, is at 0, -8. So let's put that in. So 0, -8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so let's now get the vertex form. So see the negative out front, we're going to have to pull that out of the first two terms. That's going to change the sign, leave your space, right? Keep it outside, and so then divide that middle term in half and square it. And remember, because of that negative outside, we actually just added a -9. So because that's a -9, I'm going to use a +9 out here to zero it out. Okay, so -8 plus 9 is a +1. So there's our vertex form. So now we know that our vertex is at -3 and 1. We also know from both the standard form and this equation that it's as if we have a slope of -1. So let's go to our vertex of -3, 1, and make a slope of -1. See the parabola starting to take shape, looking good. All right, let's try now the factored form. So remember, we can divide out that negative, right? Divide out the negative from our standard form so that it's nicer. What would multiply to 8 and add to 6? How about 2 and 4? So x plus 2, x plus 4, which means that our x-intercepts are the opposite. And of course, this had a slope of -1, so it's opening down. So x equals -2, and look, we already drew them with our slope, so isn't that lucky? Okay, and then just draw in our parabola. That was a terrible job. Sorry, it's so hard to draw on the computer, guys.